Before we dive into the hidden corridors of wartime science, I want to invite you to subscribe to the channel and comment below with your favourite World War II discovery. This isn't just history, it's a lens to see how desperation, innovation and accidental genius reshaped the modern world. By the end of this video, you'll not only uncover hidden wartime breakthroughs, but also understand how they can inform survival strategies, engineering solutions, and scientific thinking even today. How radar transformed both warfare and everyday technology. During World War II, radar was initially developed as a secret weapon to detect incoming enemy aircraft. British scientists working under immense pressure refined the early detection systems into a network that could pinpoint planes from miles away. What's remarkable is that these wartime experiments laid the foundation for technologies we take for granted today, including media group, archival air traffic control towers with radar screens, early weather radar images, meteorologists using radar displays, stock and distribute equally, air traffic control, weather forecasting, and even modern automotive collision detection systems. For survivalists or outdoor enthusiasts, understanding the principles of radar can translate into practical applications. Simple lessons about signal reflection and wave propagation, for instance, can be used in designing improvised motion sensors or early warning setups in remote survival camps. Studying the way radar detects subtle environmental changes teaches us how to adapt scientific principles in the field with limited resources. How penicillin went from laboratory curiosity to life-saving drug. Penicillin, often called the miracle drug, might never have become mainstream if it weren't for wartime necessity. During World War II, Allied forces faced rampant infections among soldiers, from minor cuts to battlefield wounds. Researchers accelerated production methods to meet urgent demand, turning what had been a laboratory observation into mass-scale antibiotic therapy. The accidental discovery wasn't in the medicine itself. It was in the techniques developed to manufacture it efficiently. For modern survival enthusiasts, this underscores an important principle. Small-scale knowledge of microbiology can be life-saving. Learning about natural fermentation or basic antiseptic preparation can help you prevent infections in austere environments. You can even experiment with simple, low-tech cultivation methods to understand how antibiotics interact with bacterial growth, giving you critical insight for emergency preparedness. How synthetic rubber changed mobility in unexpected ways. Natural rubber supplies were cut off for the Allies, prompting scientists to develop synthetic alternatives at unprecedented speed. This breakthrough not only supplied tyres, boots and military vehicles, but also initiated a revolution in materials science. Today, synthetic polymers dominate countless industries, from medical devices to outdoor gear. In survival contexts, understanding the properties of synthetic rubber and plastics can inform how you improvise waterproofing, flexible seals, or makeshift containers. For example, knowing how heat and pressure affect polymer materials allows you to mold or repair equipment when conventional supplies are unavailable. So, nuclear research, you see, has really changed the world, altering both warfare and energy in ways few could have predicted. The Manhattan Project, perhaps the most infamous example, started as a quest for a bomb, but actually led to discoveries with massive global consequences. While the immediate focus was, of course, creating a weapon, The project also drove advances in nuclear physics that would eventually fuel civilian nuclear energy and revolutionize medical imaging technologies. The knowledge gained from things like isotope separation, chain reactions and radiation management, well, it has applications that reach far beyond the battlefield. In practical terms, survivalists today can learn to respect radiation, while also safely harnessing related technologies. This might include understanding radioactive decay for timekeeping experiments, or even exploring how radiation can be used in sterilization techniques. Ultimately, these are lessons in both caution and innovation, really showing that wartime science often has dual-use potential. How jet propulsion accelerated the future of flight. Germany's V-2 rocket program was originally intended to devastate enemy cities, but the scientific principles behind high-speed propulsion and aerodynamics had far-reaching consequences. Post-war, Allied nations recruited German engineers, turning wartime secrets into the backbone of the space race and commercial aviation advancements. For practical application, knowing the basics of propulsion and fuel efficiency can help in scenarios ranging from small-scale model rocketry to planning long-distance evacuation strategies. Understanding thrust, aerodynamics, and energy conversion isn't just academic. It can guide anyone working with vehicles, drones, or makeshift transportation in survival scenarios. How synthetic dyes and explosives unexpectedly benefited civilians. Many chemical processes initially designed for explosives, dyes, or chemical warfare found peacetime applications almost immediately. For instance, TNT byproducts led to synthetic fertilizers, while chemical stabilizers improved industrial plastics and paints. Learning the chemistry behind these processes can be surprisingly useful in survival and prepper contexts. Improvised methods for soil enrichment, water purification, or even emergency signaling can draw from the same reactions studied by wartime chemists. By understanding the principles, you gain the ability to manipulate materials safely and effectively when conventional solutions aren't available. How interdisciplinary teamwork during war fostered modern innovation. Finally, one of the less tangible but crucial discoveries of World War II wasn't a substance or machine. It was a method. The war forced scientists, engineers, and military strategists to collaborate across disciplines at a speed and scale previously unseen. This approach accelerated problem-solving and left a lasting legacy in project management, systems thinking, and applied research. Survivalists can apply the same principle, integrating diverse skills from foraging and navigation to chemistry and engineering, multiplies effectiveness and resilience. Learning to coordinate knowledge across fields can make the difference between improvising successfully and facing avoidable failure. Every one of these discoveries carries a lesson. Science thrives under pressure, and the most unexpected breakthroughs often arise from necessity. Whether it's understanding materials for survival, applying microbiology to prevent infection, or appreciating the physics behind radar and propulsion, World War II provides a masterclass in practical innovation. History isn't just about the past, it's a toolkit for preparedness, adaptation, and ingenuity. If this journey through accidental brilliance intrigued you, make sure to subscribe to the channel for more deep dives into wartime science. Share your thoughts in the comments about which discovery you'd most want to apply in a survival scenario, And don't forget to share this video with fellow history enthusiasts who value knowledge that is both fascinating and actionable.